Okay, so here we are walking around. Now, as you can see, we can sort of, as the camera gets close to an obstacle, it moves, right? So the camera is some distance away from our player, and then as we come in, it's sort of blocked by the model and comes closer, and then as we reach a certain distance, of course, we get close to the camera's near plane, and the model becomes transparent. So let's see if we can implement that. Okay, so we'll just get this started. Now it's important to sort of look through the code, and there's sort of one thing which I changed, and that was just behind the scenes to improve the stability a little bit. I changed the movement code. So in this fair bit here. In this movement code, what I'm doing is, oh, it's actually not the one I'm thinking of. Here we go. In this movement code, what we do is we move in one direction at a time. So first we just move in the X direction. Okay, so I was just checking over my own code. So we move in the X direction. Let's say we move 10 units to the right or something. We want to actually look not just in the coordinate boxes that we're currently occupying, but we want to look 1 unit to the right in the X. So I've got this expand quickly function, which I call in all 3 cases based on the 3 velocities. So each time I'm looking ahead by 1 step, as well as in the boxes I am in. And that means that I can avoid sort of recalculating all of the coordinates each frame. That's a bit much. I mean, avoid recalculating all of the coordinates for each of the dimensions. We just move in each of the dimensions independently, and then we recalculate our coordinate in one go at the end. But the important thing is this basically improves the stability. So let me just pop over to the scene generation. This is getting a little bit big. And no, I don't want to update Steam. Why is it? Thanks, Gabe Newell, but I don't want to update. Okay, so just increase the density of blocks and give this a shot. And hopefully we should be seeing that it's pretty stable. Definitely more stable for platforming than before. So the player always sort of comes in at the ground, at the appropriate ground level. It's good. Movement's a little janky, but I'm happy to leave that for now. So also I changed the sky map. If you look at my Python GUI programming, I wrote a sort of grid editor that takes a generic sky map image and splits it up to get nice seamless sort of matches. So as you can see here, we cannot see the seams of the sky cube. Anyway, so all well and good. This is what we have so far. So I just want to go in and set this up so the camera sort of traces. And to do this, I'm going to need a few things. I'm going to go to the geometry package, and then just below move, I'm going to write a function which will tell me for a given sort of position and direction, how far can we travel before we intersect something, either the ground or a box. Okay, so we take a given position and direction, and we want to sort of start at the position and step outwards in that direction until we hit something. So I'm going to have a variable length, and I'm going to have a length increment, and let's go. Let's keep looping. So we'll keep going while we have not exceeded our maximum length. first thing we'll do is step forwards. And then we'll set a test position. Okay, excellent. And then we just need to write a whole bunch of statements, basically. Okay, so we do a whole bunch of tests. If we have gone below the ground, then yeah, we return that length. That's as far as we can go. If we hit an object, then yeah, we return the length. That's as far as we can go. Now, I just realized I should probably be stepping backwards by one step because this is the step which failed, if that makes sense. But anyway, there we have it. And then if we run through the whole loop and we did not hit anything, then just return the maximum length. So the idea is the camera will want to be a maximum of 10 units behind the player, but it might not be able to go that far because of its orientation. Okay, so I also need to go to my box class and write a has point. This will take in a point and indicate whether that point is inside the box. Fair enough. Let's go ahead and do that. It's actually really pretty much just a copy of the overlap function, but just adapted for a point. Okay, so here we have some x tests. So we'll test that against the x coordinate of the point. In other words, if our right, what is this? Our rightmost point is further left than the x, then yeah, that's not good. And similarly, these tests will be done for the y coordinate. And these tests will be done for the z coordinate. Okay, good. So I'm happy with that. Now we can go over to the camera class. And this could be a little tricky, could be a little confusing, because if we go in, first of all, everything's confusing right now because this file's getting pretty big. But if we look at the camera class, then we could say, well, where are we going to move the camera? We have this move function. Should we do a test here? We have this strafe function. Should we do a test here? Move forwards. It's a little bit weird. And the answer is I'm going to do the move test in the update function. So I'm just going to pretend, okay, the camera can move as normal, but then the update function is like a final check. Like, hey, does the camera have a clear line of sight from itself to the player or to the target position? So we can fill that in. So what is this? We have this, what is it? This self arm length. I'm going to make a variable here called max arm length. Okay, so it will attempt to, starting from the target position that it's looking at, it will look backwards. So we take the negative of that vector. Starting at a length of 0.8, it will attempt to sort of look back to its maximum arm length, okay? And then we can run some tests. So we're going to move the camera based on not self arm length, but our maximum arm length. And yep, this is fine. We have this threshold here. We're going to do the test based on the max arm length. So I think, fingers crossed, this should be okay. We can fire this up, have a go. Okay. We move forwards. It's a little messy. It's a lot messy, actually. But it is sort of stable. We can jump on. and that's a little more stable. But anyway, there we have it. Now, there are more precise ways of doing this. For instance, ray tracing. So these are actually axis-aligned bounding boxes, and there are faster, more accurate methods for tracing those. But in a pinch, this works okay. Yeah, there are some sort of issues, but we can always mess with that a little bit. So let's go with maybe double that. See what that looks like. That's really bad. Okay. So as you can see, this is not an exact science. Perhaps if we go with the original 0.8, but we simply don't subtract it in get length to hit. Just see what happens there. I mean, I guess that's a little better. It's a little better, I guess. No, okay. Executive decision. We'll keep things the way they are. That's fine. So again, we can run this and it's a little bit very messy, but that's okay. Anyway, okay, so where was I? A lot of talking. So we have that. The next stage is I want to render it so that the camera is see-through at some points. So I'll go to the fragment shader and I'll introduce and apply that to the object. And then we can go to the renderer. We can go to the renderer class down here and get that location. So query shader locations, we'll get alpha location. And we'll also set the blend function. Oh, it's already set there. Because I accidentally wrote this code and then deleted it because I realized I was writing to the wrong file. So anyway, we have the blend function set. So we're blending and the factors are set here. So we're blending based on the source alpha. Okay, so now we go to render. And let me just check. How is this going? Okay, so we draw all of the blocks and then we go to draw the player. And before I draw anything, I'm going to set the alpha to 1. And then when I go to draw the player, I will adjust the alpha. Okay, so I'll get the distance to the player. And I'm only going to adjust the alpha if we are within a certain distance, which of course, like everything else, can be tuned. So I don't want the alpha to be less than 0. what I'm going to do is I'm going to take 1 minus... Actually, I'll do this. Take that, and to make it a bit more sharp, we can square it. So then all we need to do is set that alpha in the shader. All right, good, good. So let's give that a shot, see what that looks like. Okay, so here's our player, we get close. Uh-oh, what's going on there? So just adjust that. It doesn't quite seem to be working so well. Okay. Little messy, I guess, but yeah, there it is. So yeah, we bring it up, get closer to the player, and then the player becomes see-through and doesn't block the camera. And if we just get into a position where we know an object is going to block us, then we can go around. And it brings the camera closer. Cool. So, there we have it. Little weird with the ground, but it's it is what it is. Okay, cool. So there we have it. I'll leave that there for now. And yeah, hopefully that was fun. And I'll, see you again soon. Bye.